Okay, part B. The number of people with type O negative based on a simple RAM sample of 10 is recorded. According to the American Red Cross, 7% of people in the United States have blood type O negative. So our N here is going to be 10. Our success is going to be people who have O negative, which is about 7%, so take that out of percentage, 0.07. So failure, people who don't have that type of blood, 1 minus 0.07, or 0.93. And all the values of X, or how many people could have type O negative blood out of 10 people. Well, nobody could have, or everybody could have, or everywhere in between. So you can start from 0 and go all the way up to 10. Okay, so to make sure that this is binomial, it's got to fit those 4 rules. So, are there a fixed number of trials? Well, yes, there's only 10 of them. Are the trials independent? Well, yeah, just because this person has type O blood doesn't mean that this person is going to have that type. So they are independent. One does not affect the other person. There's only 2 outcomes. Well, yeah, either you have type O negative or you don't. And the probability of success remains the same in all trials. Yeah, the probability of success remains at 0.07. So this is binomial. Part C, a probability experiment in which 3 cards are drawn from a deck of cards without replacement and the number of aces is recorded. Okay, if we go through those 4 steps, or those 4 rules, number 1, is there a fixed number of trials? Well, yeah, I'm only drawing 3 cards. Are the trials independent from each other? Well, we can stop right there, because what does without replacement mean? Remember, that is code word for dependent. So since it fails at number 2, this is not binomial. You stop right there. So in this we're going to see which ones are binomial and which ones are not binomial. If they're not binomial, where do they fail at? So number 1, telephone surveying a group of 200 people to ask if they voted for George Bush. So is there a fixed number of trials? Yeah, 200 people. Are the trials independent? Well, because one person, say, voted for him, that doesn't mean that the next person is not going to or are going to vote for that person. So yeah, they are independent from each other. There's only 2 outcomes. Either you did or you did not vote for that person. And if it doesn't say that the probability of success has changed, we're just going to assume that it remains the same. So this one is binomial. So that one checks out. Okay, number 2. Count the average number of dogs seen at a vet's office daily. Well, is there a fixed number of trials? Well, I don't know, because they don't say how many dogs that they saw. So it doesn't sound like there's a fixed number. So this one fails at number 1. So it fails at number 1. Okay. You take a survey of 50 traffic lights in a certain city at 3 p.m., recording whether the light was red, yellow, or green at that time. So fixed number of trials is 50. Trials must be independent. Okay. There's only 2 outcomes. Well, nope. It can be red, yellow, or green. So this one fails at number 3. Okay. You were at the fair playing pop the balloon with 6 darts. There are 20 balloons. 10 have a balloon that say, or have a ticket within the balloon that say win. The other 10 have a ticket that say lose. Okay. So here's our stand, and here's all the balloons. Okay, now when I go to throw my dart and say I hit this one, well, it goes away. Now, at the fair, they're not going to say, okay, whoa. Let me go replace that balloon that you just popped and let you try again. They're just going to say, okay, now go ahead and keep going. All right? So with that in mind, are there a fixed number of trials? Well, yeah, you've got 6 darts, so you have 6 chances. So your trials would only be 6. Are the trials independent from each other? Well, say I start off with, I'm the first person, okay? I start off with 20 balloons, and then I pop one, and then how many balloons do you have left? Well, you have 19. Okay, and then 18, and then go on and forth, okay? So if it keeps going down, well then it's really without replacement, because a person is not going to say, whoa, let me go replace that balloon that you just popped. Okay, they're just going to say, yeah, you just keep going. So this is without replacement, which means it is dependent. So this one's going to fail at number 2. So it fails at number 2. Now these are just for you if you happen to forgot, or what phrase goes with what symbol. This is just for you to look over. Now I'm about to show you a formula, and it's used for binomial probabilities only. Before I show you this formula, do not freak out. Okay, here we go. Here is the formula for binomial probabilities. Now I'm going to change it just a little bit because of the calculator that I asked you to get at the very beginning of the semester. It should have combinations somewhere, which would look like this. There should be a button on your calculator that looks like this. Either you have it like a button like this, or you've got a PRB button, which you hit that and you'll have 3 options. I believe it's NPR and then NCR and then factorial. Or you could have a button, say it's x squared. I don't know if it's x squared or not. And then right above it, you have that button, where you would have to push the second function in order to get this right here. Okay, so there's 3 choices out there. But if you got the calculator that I recommended, then you're going to have a PRB button. That's the one that you would have. Okay, now I'm going to change this part right here. So really what we're going to be using is NCX, P raised to X, Q raised to N minus X. Okay. So N is basically what we've been trying to find. A number of ways something can occur. C is just combinations. X is what we're looking for. Notice how these are the same thing right here. X, 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 and X. All those will be the same number. P is our probability of success, what we're looking for, and Q is the probability of failure. Okay, so like this one, according to the CTIA, 25% of all U.S. households are wireless-only households. In a random sample of 20 households, what's the probability that exactly 5 are wireless only? Okay, well, we're looking at an N of 20. We're trying to find exactly 5, so X is equal to 5. Okay, and then the probability of success, where a success here is having wireless-only households, well, that's 25%. So we're going to get that out of percentage. And then Q, failure, which not having a wireless-only household would be 1 minus 0.25 or 0.75. So then we're just going to plug and chug into our formula. So P of 5 is equal to 20 combinations 5, and then 0.25 raised to 5, and then 0.75 raised to 20 minus 5. Now I'm going to do one thing, clean it up just a little bit. Go ahead and make that 20 minus 5 just 15. Okay, now this is the fun part when you try to enter this into your calculator. Now what you're going to do is you're going to mash or enter 20 and then hit that PRB button, and you're going to use this arrow here. It looks like this. you're going to be using this button to scoot over until you see NCR. Then you're going to hit enter, and then enter 5, and then hit enter, and then times 0.25. We call it a caret 5, but it should looks like this right here, and then times 0.75 caret 15, and then hit enter. And what you should come out with, this should be equal to 0.2023. Okay, so this is the 0.0 or 0.2023. That's the probability of getting exactly 5 households out of 20 that are wireless only. So you have about 20% chance of that happening. Okay, fewer than 3, this is going to be P. X is less than 3. Okay, so P could either be a 0 or 1 or a 2. Remember, or probabilities, you're going to add these. Probability of 0 plus the probability of 1 plus the probability of 2. Now, since I have 3 probabilities, guess how many times I'm going to have to use that formula? Yep, 3 times. Okay, so for this first one, okay, this is going to be equal to 20, combination 0, 0.25 raised to 0, 0.75 raised to 20 minus 0. Okay, and then plus, we'll move to the next one. So plus 20, combination 1, 0.25 raised to 1, 0.75 raised to 20 minus 1. And then we'll move on to 2. Okay, plus 20 combinations 2, 0.25 raised to 2, 0.75 raised to 20 minus 2. And of course, you can clean this up just a little bit. You can make this 20 minus 0, 20, this 20 minus 1, a 19, 20 minus 2, an 18, and this 0.25 raised to 0. Anything raised to 0 is just going to be 1, so you technically don't have to include that into your calculations. So you could clean it up to make it look like this right here. So you can put all this into a calculator if you want to, or you can go step by step. Find this one, and then this one, and then this one. So the first one should be 0.0032. The second one should be 0.0211. And the third one should be 0.0669. Okay, now when you add all these up together, you should get 0.0912. Okay, so that right there, so what you can say is in a random sample of 20 households, fewer than 3 will be wireless only, and you have about a 9% chance of that happening. But this would be your final grade.